Hey everyone, my name is Harry Tormey. I'm the CTO of StepChange.work. We are a boutique consultancy with the world's best experts solving application and database performance issues. Today we're going to be talking to Andrew Atkinson, who is a Postgres expert who works with StepChange on some of our commercial engagements. And today Andrew is going to be talking to us about the world of Rails, Postgres performance, and all of those sort of good things. So, Andrew, over to you. Why don't you introduce yourself?
Thanks for having me on, Harry. Excited to be here. So I'm Andrew Atkinson. I've been a longtime software engineer, more than 15 years. And the last 5 or 6 or so, I've been really focused on Postgres as a specific relational database, but really from the perspective of usage with applications. Having worked at different companies and on different teams, I felt like there was this kind of specialization area that was often needed as companies reached a certain level of scale where it would be interesting to offer that on teams I'm part of, or now I'm offering it as a consultant as well. And it's been a pretty fulfilling process to go through and work on building these very specialized skills. And then, meeting with different companies through this consultancy practice that I'm performing now for different companies. But yeah, I guess my general background as a technologist is having been a application developer, mostly web applications with some of the bigger companies have been Microsoft and Groupon, and then a lot of startup companies, a lot of kind of venture-backed internet scale companies that are in a growth mode and then going through that journey a couple of times at different places.
That's a really awesome background. And it's great that you've worked on Rails performance issues at Microsoft as well as kind of early stage startups. So, tell me a little bit about how you first got into database performance issues. How did you cut your teeth, Andrew?
Yeah, I've since learned the term accidental DBA from charity majors, and I was on a small team where we were kind of looking at performance holistically as we were scaling up. That was, things outside of Postgres and the application as well, but it could be other databases or,
What was the
yep.
application stack that team was working on, Andrew?
Yep. Yeah. That was a Ruby on Rails monolithic application running on Postgres 10. And we were deployed on AWS with Elastic Beanstalk and RDS. And the where I really cut my teeth was there was this opportunity. There was both a need and an opportunity to really help the team in this specific way as we were all kind of scrambling with past load that we had experienced and then knowing that future load was coming, but in a quiet period. And the reason that that's not usually the case, usually you don't have that sort of up and down pattern. But in this case, the reason was because it was an educational app used in K through 12 schools. So there was big load during the spring semester or the spring time period before school was out, and then almost nothing at all in the summer time. And that's when I was primarily performing this work. But we knew that we were performing it because in fall we expected a huge, crushing load of traffic again.
And could you tell us a little bit about the read and write characteristics or other interesting things about this educational application, just so our viewers understand and have a mental model of what the database's needs would have been?
Yeah, definitely. And uh, the I did actually do some product work. We didn't. We kind of had this. We were about 5 or 6 total engineers on that team, so we didn't really have divisions like an infrastructure team and a product team and that sort of thing at that point. Later on, as the team size grew, there were those kinds of divisions. But I was mostly working as essentially an application DBA in that summertime period. But I wasn't working super efficiently because I was learning a lot, and I had this opportunity to learn and apply what I was learning there. But going back to the way the application worked, the reason I was mentioning all that is because later on I actually did more product development, but I kind of went back and forth a bit, which is actually how a lot of my career has gone. Is I've kind of gone back and forth a bit between application development and then more of an infrastructure focus. And the application was a video sharing app, so sort of like TikTok, something like that. But specifically for use, imagine one that's designed more for kids. So it's going to have like a really fun and silly UI, like a lot of stickers and effects and things like that, which I guess TikTok does too. But but it's going to be, and then it's going to be used in a real specific way that's more meant to be a somewhat private interaction between like a teacher, an educator, and their students. And it would augment the classroom learning. So it would be like creating a video about a topic, asking for video responses from the students, creating some engagement, and being able to do that, using the internet and using mobile apps. And so the patterns then were, of course, writing in a lot of video and metadata types of comments, data about the video. And then a lot of, I would actually classify it more as kind of a social media style app, where a lot of the problematic patterns that we ran into were social media interactions. So like likes and views and comments and that kind of thing, and making sure that interaction, which was coming in really fast all the time, was performing well, so it was efficient with lots of, with millions of interactions. And so yeah, a lot of the way that sort of shook out, which I can get into more, is with relational databases. The challenge there is relational databases provide a lot of strong guarantees about your data and about the transactions that you're sending it. And so there's a balancing act there where the more guarantees that are provided can impact your concurrency capabilities from your client application or how you use the database. So we were looking at things like better understanding the impacts of multi-version concurrency control when we just update a column on a row. So like this particular video, its relational database table row has a view count. We want to just update the view count. Turns out that's pretty hard to do when you're doing that millions of times in a short time period. And so, just learning about why that is in Postgres, what our alternatives are, how we can optimize in place, those sorts of things were a lot of what I was focused on at that time period.
So, okay, to read this back to you, Rails application, probably, ORM is a very compelling point about this from an application developer's point of view, right? Like you get to just write code really quickly without thinking too deeply about the database. One of the use cases in an application like Twitter or YouTube is how many people looked at the thing. In order to keep that updated and accurate, you have to do a lot of writes to the database that may not be apparent to the application developer. Can you walk us through maybe some features from an application developer's point of view that would be problematic?
Yeah, it's a good way to think about the tension, I guess, between kind of the application developer's needs and the persistent store. Like the data store is all about, I'm making guarantees about, if you send me data, and I'm going to go through lots of hoops to make sure that it's going to be there, even if the database restarts, and, I can give you lots of things like the ability to replicate it to other instances and things like that. But those are it's a different set of problems being solved than I need to build a video feature, and wouldn't it be cool if like at a certain timestamp I could leave a comment or something like that. That's a whole different set of problems that a product developer is looking at. And yeah, with an ORM, which is active record in Ruby on Rails, or really any ORM, the idea is it's an abstraction layer on that interaction with the database as we send, read and write queries to the relational database. And by design, so that the product developer doesn't need to think about or even really know much about how that works. And that actually works really well for a long time. Like Postgres, other relational databases, they're general purpose relational, or they have a relational model, but they're general purpose data stores. And what I've seen is, and what I talk about with some clients that have hired me is understanding, like you said, thinking about some of the ways that certain features might play out in a non-optimal way in a relational model. And actually that's more what your question is about. So let me go into that first. So I would say, there's a combination of things to look at. One is, first of all, is kind of just the instance that is serving the traffic, right? You typically, sometimes it kind of boggles my mind how we generally have one primary Postgres instance that's serving all of this traffic, all of this write operations, concurrent write operations from lots of different users as they're generating activity from an application, creating objects, metadata, comments, just doing things. Basically, that all needs to be persisted. And then simultaneously, we're serving the most up-to-date version of whatever's happening out to likely many, like a multiple, what's the word I'm looking for? The
multi-sharding. Are you talking about having multiple read instances?
I wasn't saying we're serving data out, but at a order of magnitude higher typically, right? Like we commonly have something like can be like a 10-to-1 ratio of read activity to write activity is not uncommon with a lot of web applications. So we need to serve this data back, and this is all typically one server instance. There might be read replicas and other things to split traffic out to.
So from a product developer point of view, because especially with early stage startups, after the thing has been built, it's easy to go back in retrospective and say, oh, we've done all of these experiments and we now know that the product is going to look like this. But when you're actually starting to try and figure out the sausage recipe, you're iterating and doing all sorts of crazy stuff, and it's total chaos, and it's hard to have a sort of defined thing, especially for consumer applications, to optimize. So to give people a mental model about when they're starting to enter into the danger zone, would you say typically it's things that are very read and write heavy, right? Say maybe an interactive chat app that would cause performance issues versus things that are maybe more read heavy.
Yeah, it's a good question. And I guess I've been so focused on typically starting from Postgres and then kind of working back towards the application that I don't tend to think about it as much these days. But I do think, in terms of categories applications, real-time applications, there certainly are examples where folks do use Postgres for, capturing kind of like very high ingestion rate stream of changes, like that you might find with a real-time application, like a very heavy write pattern. But I think doing that, again, with Postgres being a general store, doing that without pretty significant knowledge of the ramifications of that in Postgres is not going to work very well. It's possible to do, but I think you need to really understand, essentially the operational model for heavy inserts and then maintenance and a bunch of other things. So I tend to, a lot of my career has been on I like the term information systems, but you could call them often, or maybe it's because more recently I've worked more on multi-tenant kind of business to business apps that they don't really have these huge spiky patterns that like social media style apps or maybe real-time types of apps might have, or flash sales or things like that. When you are dealing with those are some of the, those are some of the categories where the relational data model is going to be, you're going to likely run into problems faster. And I think a lot of it is the concurrency and the contention for shared resources. And as someone who has put a lot of energy into like how you can better leverage Postgres to handle those situations, where my brain goes is just like, well, just run two different instances, like segregate your traffic. There's sort of like, as a general store, I think the fun part about, being kind of solutions focused with Postgres is there's just so many things you can do with running different instances and configuring them differently, like different, there's another, I can talk about that more. But the way that a lot of client companies I help are using Postgres, or a lot of teams I've been part of, they don't have that kind of mindset or that sophistication level to say, certainly not to start out that way. So it's often about like, okay, well, where are things at now? We have these application patterns, heavy writes and reads to the same table, thousands of concurrent clients accessing it. We're running into, and then meanwhile, developers are creating new features and modifying the table in place, like with schema evolutions that are kind of rolling out and being deployed. And we're a modern DevOps organization, so we run multiple releases per day. Those are usually the circumstances where I tend to get involved, I think, and trying to juggle those things and just kind of accept where things are at the moment, helping clients show maybe what things could look like in the future. But really, it's usually kind of addressing the current, one instance serving a lot of different scenarios.
So let's kind of take a step back and talk about maybe one of these scenarios, because I think it's very sort of applicable to both the B2B use case that you talk about, as well as maybe the more consumer one that suddenly is being featured in Hacker News or is on CNN and is getting tons of traffic coming in, which is the sudden spikes of traffic. And maybe talk through, where does a Rails monolith on Postgres start to break?
Sure, yeah. Some of the categories definitely are connections from the application to the database. And then looking at the operations, like the right operations and a certain path for optimizing those, which could be moving, if the tables are very large, moving to partition tables. And that's because you can have less contention because you can have different buckets. The way in Postgres with partitioned tables, you just have more tables. You just divide up a big table into a set of smaller tables. And then on the read side, again, looking at the operations, the read operations, there's a pretty well-known path there of creating a read replica. And in Postgres, you can actually do a couple of different types of replications techniques. You can do physical replication or logical replication. With physical, you just get a full copy of your server instance running in a read-only mode. So as long as your application framework or another library that you use allows you to do this, you can split any of the read queries to that separate instance, and then you can separate the load that would have been on that primary instance out to its own instance. So that could be, if you've got a 500 gigabyte Postgres instance, like its memory that's available, you could have a second one that's solely for the purpose of reads. And there's some caveats to that, of course, with replication. It takes a bit of time to send a lot of bytes of data over the network to another instance. But there's even some modern capabilities from different cloud providers where they've nearly removed replication lag from the equation with separating compute and storage. So I've worked on a team that used those kinds of technologies where we could more easily separate our read traffic from our write traffic. And then I think there's a lot of interesting performance. So as far as I guess let me go back a bit to your original question about some of the points where you run into issues. The connections one I mentioned was typically the application will have, database connections to Postgres are fairly costly. They have process forking that needs some instance resources, some memories allocated to that process. And because of that, there's some latency incurred whenever a query needs to run and a process is forked. And to get around that, then we can keep kind of a set of connections open and in an idle state that can be reused.
I'm going to have to jump in here and ask a question.
Oh yeah, go ahead.
Thoughts on PG Bouncer, or things that people should be thinking about when they're managing these expensive connections, and maybe stuff about limitations on that people should be mindful and aware of?
Yeah, for sure. Yeah. So typically applications don't, at least with Postgres as you're scaling up, you don't really need a connection pooling software or a connection management software outside of what's provided in the framework, because it does its own kind of connection pooling and reuse. But as you're nudging me towards, commonly, again, because these connections are costly, and if you have a social media type of app, it's not, it's likely that you could get into the thousands of concurrent connections that are actively performing work. There's PG Bouncer is one of a set of softwares that are called connection poolers, and they act as kind of a proxy layer between the application and the database. And they can more efficiently reuse connections by kind of pumping more transactions through them possibly. But there's a bunch of caveats. So like with PG Bouncer, there's several pooling modes that it makes available. And there's a tension between getting more transactions processed on the same set of connections, but taking away some of the features that you might need on your client application side. So things like prepared statements or advisory locks or some of the things that you might otherwise be able to use, you can't use if with certain pooling modes with PG Bouncer. And that's another piece of software you need to run as well. So that's a bit of work to set that up. And for that reason, some of the cloud providers either offer a variation of Postgres with a connection pooler built in, or they do offer a connection pooler as a service that you can add. That's of course going to be configured already for without network connectivity issues to your Postgres instance. And that's going to allow you to then reach greater numbers of concurrent connections without running into issues that you might run into if you connected directly to Postgres.
That's a really good answer, Andrew. So before we kind of resume the conversation, top analytics or telemetry tools that people should configure, especially if they're thinking about bringing in an expert like you to help deal with the issues that they're having with their application and database performance?
Yeah, for sure. Yeah, there's reactive, and I think it's a cliche, but the crawl before you walk sort of concept. I think initially it's a reactive process from writing your application code and building your feature set, attracting usage. Usually clients that come to me, they are successful, which is great. Their business is growing and they have users. And a lot of new startups, like that's what they're fighting against initially, is just no one knows about our product. Where are our customers? Like, how do we sell to them efficiently? And all that stuff. Like that's your first challenge to solve. But if you've reached that successful point where you have usage, then from a reactive point, the very first thing to try to get in place, in my recommendation is, or my opinion is, PG stat statements, which is a well-known, it's delivered as an extension, but it's part of core Postgres. So it's called a module. But the idea is that you have all these queries running. The idea is that it provides you visibility into what are our most resource intensive queries, or queries like accessing and writing the most bytes of data, returning the most rows, that sort of thing. So it's really critical to say, like, where should we be spending our time? And what you can do then is you can use SQL to then query that. You enable it, it starts to capture your query statistics. And then you can use SQL to then query your own statistics. And you can say, let's look at what our most problematic queries are. That's definitely a reactive approach though, but what you're doing is you're trying to identify where to spend your optimization efforts. And then once you've identified that, another thing I recommend is there's what's cool is there's a standard around this now, but there's a standard called SQL Commenter with support in a variety of frameworks and languages. Harry and I, we've looked at Python and Django. There's also support in Ruby and Rails. There's support in Go and some other languages and frameworks. And what that does then is, as your queries arrive to Postgres, before they're sent from the application, you can kind of annotate or decorate your SQL query text with information about the application. And that's going to be super helpful when you start from a reactive approach and you look at queries to know where your application code is that generated those queries.
Super important, because if you're not a database person and you're used to basically dealing with users.object that has God knows how many joins or whatever in it, or other objects that are causing problematic query patterns, being able to connect what you're seeing in the telemetry to the application business logic is super critical. So please do continue, Andrew. That's an awesome point.
Yeah, and really before, query optimization is, over now 7 or so months of consulting, I have really gained a bigger appreciation for how challenging and in a sense, costly query optimization can be. Like when you actually are faced with, here's the query, we can't change it. Here's the data, we can't change that, of course. It's not easy to do, even as someone who really focuses on this a lot. And that's not to say that I can't do something quickly, but it's hard to make where am I going with this? Where I'm going with this is sometimes you can make more impactful changes by going back out to the client application and saying, what can we do here, right? And so a lot of times, for example, if you have a very costly read or a very costly operation that's reading some data, it's maybe doing a count of rows, or it's just returning a huge result set or something. Before we even go down the path of what is arguably costly query optimization, can we make a trade-off of read versus write and say, let's go and keep a counter cache of the counts of this particular query. It's very inexpensive to store this data. It's inexpensive to compute it offline outside of a user's request. And then what we can do is when we query that, it's super fast, of course. We're just reading one column from like a table row.
And just from an application point of view, do you really need to know that 1,523,602 people were actually watching the view, or does it need to be roughly accurate is always kind of a question. And can you get away with not actually touching the database? I suppose a question that I have, because I'm not as familiar with you with Rails, is how hard is it to change the configuration of your Rails app to take advantage of a different database setup? Like you're going from, we have one Postgres server, it lives here, to, hey, we've done some analysis, there's going to be read replicas, and this is where you go to write. How hard is it to configure, and what do you do to do that?
Yeah, well, the good thing is that, and part of why I think Rails has continued to stay relevant and successful despite being created about 20 years ago, is it is in use at high scale organizations like GitHub, Shopify. And we've benefited as Rails developers from lots of big, things that frankly aren't really needed at smaller scale, but are needed at bigger scale. So for example, a tiny one based on what we were just talking about is if your active record code is there's a couple of different active record methods to get the count of a set of things. So you might put a SQL query together, although with active record, where you do, you read a particular table, you join to some other tables, you do some filtering on columns within those tables, attributes in your object model, and then you do a count of those things. There's this cool, if you're willing to change or use from the beginning this size method instead of count, what that does is it lets you later on choose to use a counter cache feature that's built into Rails, where you just slap another column on your table that's a cache column, and the size method is counter cache aware. So if you just add that data and you populate it, then you can take advantage of no code changes to your application code, and you can save yourself what would be a costly read query by making a very low cost read query, for example. A bigger change would be what Active Record provides for both segregating your read and write traffic to different instances. As of Active Record 6, which came out in around 2019 or 2020, they support multiple databases, and then that's been leveraged in a few different ways. So we can set up writing and reading roles, and we can configure the application models to use one of those roles, like writing and reading, depending on what it's trying to do. But even beyond that, there's automatic role switching, where like if you know that you're accessing a read-only endpoint, like you want to read data and you're hitting a get HTTP endpoint, then you can automatically have the application code will know to go to a reader instance if it's been configured. And there's some configurations options in there, like allowing some replication lag and that sort of thing. And that can spare you from having to make a lot of application changes, but then getting that benefit of read and write segregation. And then the last thing that's basically the same as that, or very similar to that, is again with multiple databases. And these are logical databases that could be on the same physical server instance or separate instances. Active Record added sharding support, and that's going to be application level sharding. But let's say you have very heavy write traffic and you want to run a couple of Postgres instances to segregate those writes. Then from the application level, you can set up configurations to map application models to those different instances, and you can call them different shards. It's a generic mechanism, so you can kind of do different things. But one pattern there I've seen where that's really useful is, again, with the B2B business type apps. They might have the exact same schema design, so let's say it's like a time tracking software or something. It's got a table to store like the hours that you've worked in and whether you created an invoice and whether you've received a payment and whatnot. There might be the same schema design from customer 1 and customer 2, but customer 2 might have much greater data volume and query volume. You can use the horizontal sharding feature in Active Record then to give each of those customers their own Postgres instance. Maybe they have small instances, but they can then be scaled independently too. So you could say customer 2, maybe they need a lot more CPU, a lot more IOPS, and that sort of thing. And that's a capability you have in the framework, which is pretty cool.
That is really cool. So Andrew, let's say I'm an application developer working in a Ruby shop, and I've gone in and I've looked at and identified the top 7 queries that are causing performance issues. And I want to go take those queries and try and figure out what in the application business logic is causing these problems and then fix them. Can you maybe walk me through some ideas or suggestions for that person that's trying to make that journey? Assuming, of course, that they've done some of the things that you've talked about, setting up PG stats, this telemetry, tagging, all that kind of stuff.
Yep. Yeah, I think going back to what we said before, sometimes there is more of a way to solve the problem without technology, but more with conversations with the product management or the product stakeholders. And, for example, there might be a screen that is showing a bunch of things, but there's no pagination. And we can go and say, like, can we introduce pagination here? We're just going to show 10 results. The user's going to have to click a little bit more if they need to get more data, but that's going to allow us to deliver a much more reliable and scalable solution as data volumes grow and query volumes grow. And, that sort of mindset, there's lots of ways to try to apply that. Kind of scrutinizing what is being accessed and making sure there isn't any unnecessary tables being joined. There isn't any unnecessary sorting and ordering. There isn't any unnecessary fields being accessed. Mm-hmm. Like one thing I did recently was working on optimizing a query where the table had something like 75 fields, and it was only being accessed in this one particular place, but it was called in high volume, where the data from that table was serialized into a JSON response. And when I looked at it, there was fewer than half of the fields were actually needed. And so we cut it down, and that we were able to first confirm with SQL that an equivalent query that wasn't using select star but was using explicit list of fields would be much faster. And then I was like, well, why? And the reason is because one of the fields, beyond the fields that were the ones that ultimately were accessed, was a JSON field with a big amount of data in it. And the Postgres is flexible in that lets you store up to a gigabyte of data in a text field. And so what can happen is if you have select star pattern in your application, then one day another developer might come along and add a gigabyte of text data in a table, and now your query that was otherwise performing fine is now quite slow because you're just moving a lot of bytes of data
and serializing them into a JSON object. I mean, that's a really cool example of something very simple, just looking at what are you actually using. Because again, if you're a startup and maybe you've kind of rammed all of this stuff into an object that actually, after all of the A/B tests have been resolved and all of the kind of user feedback sessions, it's actually just these couple of things that we need. And we forgot to get rid of that. But hey, loads of people are using this feature, and there's this just giant pile of stuff that's coming down the pipe that needs to be serialized that's just adding so much latency into it. So I love that story. So Andrew, kind of a question about database hygiene and things like unused indexes, locks. Can you talk about moving away from the application business logic when you look at someone's Postgres tables, schemas, and queries, just stuff that's like gunky that people should be doing to clean up that, and any kind of tips or thoughts there?
Yeah, for sure. So indexes for me remain like one of the most fascinating things about working with relational databases. They really just are meant to improve your read operations. They give you this more efficient to access data structure for your read operations compared with just reading all the rows in a table and trying to do a sort with kind of unordered data that is accessed. It is accessed sequentially, but it's not giving you a precise way to look up the data that you need, which is what indexes do. So the trade-off there, though, again, is it's a challenge to make a targeted index. So a lot of times what teams do is they do a best effort attempt at creating indexes. This is my perspective that I've seen, I guess, over the years. Like people try to say they make sensible decisions. Like this query is there's a few rules of thumb for index design. If the query is, if you're accessing a table, but you're accessing a portion of it, so you've got a where clause in your query, it's sensible to have an index where that same column that's in the where clause is defined as a leading column in the index, for example. So sometimes with those kind of guidelines, people might just start adding indexes. And it's not through bad intentions, but I think what I try to get clients to be aware of is to really have good visibility into whether their indexes are being used. And often what happens is they don't necessarily have that visibility. And I think a lot of folks, on product teams as well, again, it goes back to what we've been talking about a lot in this show, that, product and application developers are working with an abstraction layer. So they're trying to make their queries fast. They're adding indexes that they think will be helpful. And they might actually even be, and the other reason that makes this difficult is indexes. Postgres is making a runtime decision as to whether or not to use an index, and it's often comparing, what's being requested in the SQL query. It's not often. This is what it's doing, and it's what I meant by often was it's often choosing between alternative plans that and seeking out the lowest cost plan. And depending on your instance resources and your data distribution, so values even within a particular column, for example, can be significant. On one instance, like let's say your staging instance, your non-production instance, you might not have indexes picked, or you might have indexes picked, and then you might have different behavior in your production environment. So that kind of like non-deterministic, I try to keep that in mind because I think that and try to use that as like a source of empathy in a way that like it is hard. Like you need to have good visibility to know that your indexes are used, and really where you care most is production. You want your queries to be efficient in your production environment. So with all that lead-in context in mind, what I try to do is get folks to know, or commonly what I see is there are a lot of unused indexes. So again, people were making their best attempt at optimizing their queries, or even adding indexes they thought would be used based on some features that were coming, or applications evolved over time, and queries that did use indexes before no longer are using those same indexes, or those indexes have been made redundant by newer variations. All of these sorts of reasons contribute to like, it's not unheard of for me to see like 50% of the total indexes are just not used at all. And the impact of that.
Yeah, go on, continue.
Yeah, with Postgres, the problem with that is then we're unnecessarily slowing down all of our write operations anytime those fields within that index are being touched, because they need to be maintained in that index. And then we're never using those indexes. They're never being read.
So just to pause you, because I think there's an important, maybe too basic point, but can you explain what an index is and why it makes looking up information faster, and the implications of if you have an index and you're not using it, why this slows down the database, just so people have a bit of a clearer mental model and we're explaining from first principles.
Yep. Yeah. So the simple way that I think of indexes, because again, we're not going to get into the B plus tree design and stuff like that, but I think of it as like we're basically lifting out, let's just say a single column index. We're filtering on the users by their email address. We have a users table with tens of millions or more records in it. We want to look up a single email address. The users table has a lot of other fields in it. It could even have 75 fields of data. So one option is we could read all of the fields of all of the rows, and then we could essentially in memory, like work through that list and find it. And the index, primarily one of the benefits of why it's faster to access data is it's really just going to have the email address in it in this example. It's not going to have all these other fields. So right away we have much less data that we're going to access. And again, we're trying to, with the relational database, we're reading data off of a disk of an operating system somewhere. So at the end of the day, there is like hard disk drive or disk drive access speeds. That is like one of our fundamental limiting factors.
And paging into memory.
Yep. And then the other reason is because the heap access or the table access isn't this sequential or isn't this ordered representation of the data we're trying to access. So with indexes, it's an ordered representation designed for access, and thus anytime we access data, we want to, again, we're always trying to do that as efficiently as possible. We want to try to essentially make a judgment call as to what's the most distinct piece of data we're trying to access. Commonly with index design, that's what we're trying to do is say what amongst all of our table rows, like what are the conditions for the smallest proportion of the data? Because then if we can put that in the index, we can just laser focus in on exactly what we need. And the trade-off, though, of course, is the index is at write time. So once that original user was written in, we're paying that cost of having their email address put into the index.
Well, yes, so it's computing and also space, right? You have to kind of create the index that presumably takes some amount of operations and then store that index somewhere.
Yep. So when we create indexes, we're really just creating a definition of an index. And when we do that initially, Postgres is going through and gathering up all that data for us and creating this separate data structure in its own separate file that, again, could be accessed and put into memory. And then it's accessed ideally from memory. But we are creating that separate thing, and there's a cost to that. So there is that write time cost, and then there's that space cost. And then there's also this other subtle one where having those indexes in our memory, which is also a finite resource, means that something else can't be in there because it is a set of data that and what I'm talking about here is the buffer cache in Postgres. And so we have a finite set of memory for our regularly accessed or our frequently accessed data. We don't want to have content in there that is not useful content. That's not based on our read patterns. So
if you have lots and lots of unused indexes, maybe this is a function of ORM or product development that was, didn't go anywhere. Would it be fair to say this can create a scenario where it slows down holistically the entire database instance? Is that kind of how it manifests from an application point of view?
Well, it is tricky because I think that's too broad of a stroke to paint. I would say that it's more like, table by table kinds of operations, I guess. If you have a particular table that you're accessing frequently that's also being inserted too heavily or updated or deleted from heavily, that's where unused indexes are going to add unnecessary I/O and latency to those operations. And the other way that's a little less immediately a problem but can be a big problem is it's not unheard of, again, if you have 20, 30, 40, or even 50% of your indexes, and you have a large database, let's say you've got hundreds of gigabytes or terabytes sized database, that means you also likely have hundreds of gigabytes of index content. And that's going to slow down your backup and restore time.
And bills.
And your bills, yeah.
Yeah, because can you briefly maybe segue a little bit in terms of for people who are application developers or maybe not looking at the bottom line, like how can that get really expensive with, say, AWS and the way that they do billing? Is there anything that you want to call out there?
Yeah, for sure. Yeah, I guess I've learned about this as I've worked more on infrastructure teams and stuff. But typically, the older way of doing it anyways was you would provision your instance and you'd choose your storage up front and you'd start paying for that. I think that's fair to say. So you might say, well, we need a terabyte of space and our database keeps growing and growing and growing. And oops, now we need 2 terabytes of space. So now we're going to start paying for that. There are some other cloud offerings that give you price breaks up and down. And that actually can be really good too, to also as a reason to remove unused indexes. Let's say you can take off 300 gigabytes of space from what you actually need. I know for example, I presented on this in the past, but with Aurora, you pay in these 10 gigabyte increments. So you can actually cut your space consumption bill down by cutting space out. And so I think if you're for folks that work solely with the DB, those are some of the opportunities. There's also addressing bloat and rebuilding indexes and that sort of thing. But I think if you're more on the application side or product side, I kind of think about it more as like our infrastructure cost efficiency, and we're spending money on our application servers, on our database servers, and there's a certain cost for that. Are we getting as much as we can from them, and if there's opportunities to perform some maintenance tasks that might take a couple hours, and then you get greater cost efficiency, we're getting more IO operations for less money or the same for less money. That to me is a win as far as your operating expenses.
Before people go and just say, oh, I'm going to kill all of these unused indexes, is there any best practices about retiring an unused index to avoid any disruption to users?
Yeah, one of the main foot guns there is which I've done myself, is if you drop an index on a table that's actively being written to. A lot of times with Postgres, we're working with locks and lock contention, whether it's the table being locked or row locks. So a drop index operation is going to take a certain lock that could block other table level operations, and you can then cause kind of like partial unavailability, or outages, but not for the whole application, but for a portion of it. So Postgres helpfully gives us this option since I think 14 of dropping an index concurrently. So we always want to do that for anything that's like actually in use and busy, is to use this concurrently keyword. And conveniently, the concurrently keyword is really like in my book I wrote about this too, but like just kind of there was a title or like a subtitle, like get in the habit of using concurrently as a default. Just like anywhere you can use it. There's several different commands that support it, and kind of as a mindset, like always think about, if you have a running production application, that there's going to be contention for, could be rows. And so how do we change things simultaneously with other things while minimizing the kind of locks and contention? So yeah, I'd say using concurrently is one. And then, typically, I'm a big fan of the PG Analyze tool, which is a commercial SaaS tool. But the approach that it takes is it scans each day for index usage data that Postgres gives us. So we can just do that ourselves. Anyone can access their Postgres, I think it's the PG Stat user indexes catalog. But you can see like, are my indexes being scanned by my queries to help support read operations? And ones that aren't scanned at all are usually what we call unused indexes. What's cool about that is, and what PG Analyze, or you can roll this by hand yourself, is if you just repeat that, then you kind of gain more confidence over time. It's, if across our entire application that's using this relational database, whether it's user level kind of API traffic, or it's background jobs, or it's cron jobs, or things like that. If 30 days pass, 60 days pass, etc., there's never been one scan of an index, we can be pretty confident that it's not going to ever be used. And we can always add it back if we need it. So I think kind of getting into that mindset of like a hygiene practice of saying, periodically we're going to look at our unused indexes. We're going to remove those so that we know that we're efficient in terms of our write operations and our space consumption. I think it's a good practice.
I want to ask you a little bit more about Postgres internals, specifically thinking about the query planner or how Postgres does queries. Because I always found myself, even if I'm not a DBA or even if I'm not a backend person, just understanding how a system works helps me reason about how I build my applications to leverage that system. So can you tell me, give us a little bit of an overview of how Query Planner works in Postgres, and maybe some things to kind of be mindful from that perspective, someone who's an application developer who's maybe not going to be in the weeds that you've learned?
Yeah, for sure. I think your the way you describe that is a great idea and a great suggestion. Even if folks, I think if you have an understanding of what Postgres is doing when your query is received by the planner, and how it's going to kind of break it down, then it can actually inform how you write your interaction types of code, whether it's writing or reading data. And so, there's I think there's 4 phases, but to sort of oversimplify it, your SQL query is generated, like let's say it's generated by your ORM. It's sent to Postgres, and then it's planned, unless it's a prepared statement. We'll leave that off the table for a moment, but we'll say the planner, or also called the optimizer in Postgres land anyways, is what it's going to do is it's, you're writing declarative SQL. You're saying, I need to access these. This is what I want my result to look like. So it's going to be this set of fields from one or more tables. And then because your data is probably normalized, you're going to access multiple tables and multiple fields. You might have primary key, foreign key joins, and that sort of thing. So Postgres is going to break all that down, parse that query, and say, what are the things I need to access? And then it's going to say, how can I do that at the lowest cost? So it makes a cost-based runtime decision. So it might say that, let's say you have a users table and you have a notifications table, just making these up. But it might say that for notifications, we want to access the last notified at column, and we want to access the user ID column. I want to find this user's notifications. So then Postgres might say, well, on that table, then do I have any indexes that could support this query? Because I know I can access those at a lower cost. If I don't, I'm going to do a sequential scan on the table. So I'm going to read the whole table. And the planner creates this tree representation of what it's going to do, which is the query plan. The cool thing in Postgres is we get a lot of really rich detail that we can look at as to what any query would look like, how it's going to be planned using the explain keyword.
Is this in the logs, or where does this detail show up, Andrew?
This would be, if you have the source SQL query, this would be using the explain keyword in front of the query, which you could do manually. So it shows you like the reason why it's executing this query, gives you more context if you use that explain keyword. Yeah, it shows you the execution plan based on everything it knows about at that moment that it plans to do. It could still take a different path, but what we can do is we can also see both prior to the actual query executing using explain, or we can then add the analyze keyword. So it's explain, analyze, then your SQL query. That's going to show us afterwards what it actually did. And what's cool about that too is then it intermixes it still retains the estimated plan and the actual plan. And you can see then sometimes interesting data, like what Postgres thought. Postgres thought the number of rows were in a table versus what the actual number of rows are. Sometimes that can be off quite a bit. And then that
Why would that be off, Andrew? What would cause that to be off?
Yeah, it's a good question. That is it's one category of poor performing queries that are going to be more related to sort of your database operational health. Typically the first thing I would look at there if I was looking at that is the table is the statistics collection for the data within the table that Postgres does, which is a critical part of its query planning. It's really actually critical that that's as up to date and as fresh as possible and running really regularly. And what can happen sometimes is that slows down and degrades. And that can again happen due to if the table is very heavily, if there's a very heavy amount of concurrent modifications to row data and content within the table, then the process that normally captures those statistics will just simply slow down. And so it could be that what you need to do in that case is give it more resources. But what you want to do to kind of immediately rectify that problem is you want to do use the analyze command, for example, on a table, which will refresh the statistics Postgres captures about the row data. Because again, the row data, and this is something I talked about in the book too, this is something again that I think is pretty far removed from a typical application developer's kind of brain space or mind space. But, not only are we working at an abstraction layer, ultimately generating SQL queries to send to the database itself is also in charge with accessing data, but it's relying on statistics about the data.
So if its data source is falling behind what the actual state of the world is, its planning is going to be deficient because it's acting on faulty data, and that's kind of a signal.
Yeah, just like you or I would if we were acting on faulty data and making a selection. We're at 2 doors, we can go down door 1 or door 2, and if our goal was to, find some kind. I'm really going off on a weird example, but if one of those doors had the target that we were looking for, but we had misestimated information about the contents of those rooms, then we would make the wrong plan choice. And so a lot of times that is the circumstances folks start from is, why is the query planner or just my query slow? Then they might determine, oh, this plan selection was odd. It didn't use my index I thought it would. And then sometimes the actual root issue could be bad planner statistics. Postgres also gives us some options to Postgres can't keep track of every single row and every single column. Let me rephrase that. Postgres keeps track of samples of rows in a table, and it keeps track of statistics about things like the distribution of data within a column. And it's again trying to make a trade-off of, just like we would too at making any sort of decision. You can't know everything all the time, right? Like that's kind of the way I would maybe oversimplify it. So it's trying to collect enough information that's going to be relevant to its decision making. And sometimes as the operators, we can feed it with a little more information. We can say, oh, for this table, I actually want you to collect more samples. Or for this particular column, I want to express like a relationship that you might not know about between 2 columns.
So this kind of sounds, the way that you're describing the query planner has a lot of value from someone who's tuning maybe configuration variables around Postgres, or playing around with that. Has your knowledge of the query planner and how it interacts with Postgres ever caused you to advise maybe some application level changes? Like if you're an application developer, maybe not someone who's kind of going in there playing with configurations, does this knowledge allow you to write better SQL or debug your SQL or figure out what's going on with the ORM? Could you maybe talk a little bit if that's the case?
Yeah, I think it's really just the most beneficial and maybe coarse-grained or 80-20 sort of way I would answer that question is just understanding what is being accessed from your table data. And if you're doing a read query, making sure that you're likely making sure that there's an index supporting that read query. And the way that you would do that is you'd look at an explain plan and you'd see that an index is not being used. And then once you add the index, the explain plan will show you the index was used. So you'd access the same data, but you do it much more efficiently with an ordered data structure And something we haven't really gotten into, but Postgres shows you its own storage unit is these something called buffers.
Mm-hmm.
So when you can imagine that your row data, which lives in a data page, and then those pages can be put in as buffers into your memory, and then data's access. Probably getting into too much details here. I'd say that, yeah, the biggest thing is basically just learning to read the explain plans for the queries that you're generating. And then on the application side, again, kind of getting into a mindset of, okay, we're writing code here where we're filtering on rows, where we have kind of unbounded access to this table. We don't have any restrictions like a date range restriction or a row count limit. I have this query that is joining 5 different tables, but there's also some denormalization in effect. Like maybe we have a tenant identifier column on all of them. Maybe we don't actually need to join 5 tables. We just need to join 2. And you can see each of the costs of each of those things I just described, like whether it's kind of unbounded access versus restricted access, the costs of those joins, and how Postgres is choosing to merge that data together. And the other thing I mentioned, which I forgot about, you can see what those those are in the query plan as you make variations. And I think that then informs having that sort of mindset on the application side of trying to write things as efficiently as possible from the outset.
These are really great debugging tips, because you've given us the sort of mental model of like, hey guys, if you've really iterated on this object and you're not using a bunch of indexes, you should probably get rid of them. But then you've also sort of given another valuable tool to just have a mental model about how is Postgres using the SQL that's generated from the ORM, and is it actually behaving the way that you expect it to? Is it using an index? And if it's not, why is that? Is the row count off? Do you need to change something about the configuration? So these are really excellent pieces of advice. So Andrew, you have a shiny new Rails book out, and it would be remiss, and I want to be mindful of your time because we're over an hour here, and this has been awesome stuff. Pitch the Rails book and tell us about what's in it, and how you approached it, because there's it sounds like just a mine of information that would be really useful for Ruby devs dealing with Postgres.
Thanks. Yeah, the book is it's called High Performance Postgres for Rails. Actually, I have one right next to me right here, so I can pull it up.
Live?
Yeah, it's available.
Ooh, that looks good. And who published it?
It's they're called the Pragmatic Programmers, and I was really excited to work with them because I personally have purchased a lot of prog books, throughout my career, and think of them as a one of the publishers of the top books in the Ruby world in particular. And there's another prog book, SQL Anti-Patterns, that I am familiar with, and was kind of somewhat of an inspiration to work with them as well for me. But yeah, so the way I describe the book is it's actually like 75% Postgres book, maybe 25% Ruby on Rails. And I have had some folks tell me that they're still finding it useful even though they don't work with Rails and never have before, but they build web applications with other similar kinds of MVC monolithic frameworks, like could be PHP and Laravel or Node and Prisma or something like that. And the real purpose of the book is basically to go into more breadth and depth on some of the things we've been talking about today, which is I have an application that's working with Postgres. I'm learning more about how it works and what I can exploit, what are painful areas, how to keep things healthy, maybe some re-architecture too as I move into more advanced features like table partitioning. And that's all in the book. So it's written it's 15 chapters. It's written like in a way you could read it from the front to the end, like with a narrative style. But at the end, I also am proud of a field guide section that we added in pretty late based on some feedback from earlier readers, where it's like the opposite, where you can just start from problems. You can say, I'm having, if you have certain problems you've identified, you can look in the field guide and see if it has, and if there's any hits on the problems you have. And then it'll give you references back into the book to go and read about a certain area.
This book sounds absolutely amazing, Andrew, and I just want to say thank you so much for your time. I really appreciated talking to you, and I think anyone watching this will have a few handy tips to take back to their Rails or other kind of Postgres with an ORM application setup. So thank you so much. I'm going to stop the interview.